Okay, so I'm going to talk about heat and temperature today. So heat, a lot of times people confuse the terms heat and temperature. They get them mixed up, use them interchangeably. Heat is actually a form of energy transfer. It's a way that energy transfers from one thing to another. So you can experience heat transfer when you touch a hot object. So your hands are not actually capable of determining whether something's hot or not, or the temperature. Your hands are not thermometers. You can't determine the temperature of something. But heat, you can sense whether heat is flowing into your hand or out of your hand. So heat always transfers from a hot object to a cold object. So if you touch a hot object, heat energy goes from the hotter object to the cooler object, your hand. If your hand is hotter than something else, it feels cold because heat is leaching from your hand into that cooler object. Heat always goes from hotter objects to cooler objects. Now, temperature is a little bit different. Temperature is a measure of the tendency of heat to be transferred. Another way to think about temperature, and we'll talk about this more throughout the class, is temperature is also a measure of kinetic energy. The particles at the atomic level, the atoms are moving. Even in a solid object, atoms are moving. They're vibrating. The higher the temperature of something, the faster they're moving. So two things that have equal temperatures, their particles have the same kinetic energy. So temperature is a measure of kinetic energy. So there we go. All right. There's 3 temperature scales in use today. They differ in size of degree and reference point. So the Fahrenheit scale is one that Americans are used to, that people in the United States are used to. And it is based on a freezing point of water being 32 degrees Fahrenheit and boiling point of water being 212. Now, Mr. Fahrenheit made the scale, and no one is exactly sure what his reference points, where his 0 and 100 were set and why. There's lots of theories. No one is totally sure. But there's 180 degrees between those 2 reference points, between the freezing point of water and the boiling point of water. So hopefully you understand that the freezing point of water is the same no matter what scale we're talking about. It's a reference point that's uniform. And the boiling point of water is the same no matter what. Now, they're not numerically the same because the scales are different, but we can compare and contrast the scales by comparing those points. So on the Fahrenheit scale, freezing point of water, 32, boiling point, 212. Celsius is used by pretty much everyone else in the world and in most of science. It is based on the freezing and boiling point of water, and the freezing point is 0 and the boiling point is 100. So there are 100 degrees between those reference points. So now, remember I said Fahrenheit had 180 degrees between the two. Fahrenheit had 180 degrees between those 2 reference points. So which is a larger increase in temperature? An increase of 1 degree Fahrenheit or an increase of 1 degree Celsius? The answer is it's 1 degree Celsius is a larger degree because it takes fewer of them to get from the freezing point of water to the boiling point of water. It takes more of the Fahrenheit degrees, so they must be smaller. So Celsius and Fahrenheit are both offset by 32 degrees, and Celsius degree is 9/5 larger, so almost twice as large, but not quite. So here are the conversion factors between them. Now, I want to show you, if you know this one, if you say you're given this one, Fahrenheit, and the order of operations is very important here. If I wanted to solve for degrees Celsius, what I would have to do is I would first I would have to subtract 32 on both sides. So I get Fahrenheit minus 32. And then what I would have to do, and so I'd have Celsius is 5/9 equals there. What I would then do is have to multiply by 5/9 on both sides. Right? So these would cancel out. And what I would get is I would get this. I would get 5/9 Fahrenheit equals Celsius. So there's a different order of operations. If you're going from Fahrenheit to Celsius, and I wrote that really poorly. Going from Fahrenheit to Celsius, you subtract first and then multiply. If you're going from Celsius to Fahrenheit, you multiply first and then add. I don't expect you to memorize either of these conversion factors or either of these conversion formulas. You don't have to memorize them. I will give one of them to you on an exam or quiz if you need it. Right? However, I may or may not give you the right one. So the algebra that I just did to get the other formula, you need to be able to do that. You need to be able to do your algebra to get from one to the other, but you don't have to memorize it. I will give you one of them. And I probably won't even pay that close attention. I'll just throw one on the exam or quiz, and just there it is. So, okay, Kelvin scale. It's also a metric unit of temperature. I'll actually be able to explain a little bit later. I think in chapter 7? I'll be able to explain a little bit better why the Kelvin scale was developed. But fundamentally, it was used because we needed a scale where there were no negatives. So it was determined that the 0 point on the Kelvin scale is where there is no kinetic energy. Right? There's no kinetic energy at all. So it looks like it says okay, but 0 Kelvin is where there's no kinetic energy whatsoever. So it's the lowest possible temperature we can have, and it's sort of a universal, right? If a temperature is supposed to be the measure of the kinetic energy, then to get something that's proportionate to kinetic energy, we need a scale where the 0 point of the scale is the 0 point of kinetic energy. So that's what 0 Kelvin. 0 Kelvin is also called, some of you may know this, is absolute zero, because we cannot get any lower of a temperature than that. You can't have a negative, so it's absolute zero. It's nothing. We can't get lower than no kinetic energy. So what the freezing point of water turns out to be 273, and the boiling point is 373. So how many degrees are between the boiling point and freezing point of water? It's 100 degrees. So it's the same size as the Celsius degree, but their reference points are offset. The reference points are different, and so they're just offset by 273 degrees. So you do have to memorize this. All you have to remember is 273. If you're going from Kelvin or Celsius to Kelvin, you add 273, and if you're going the other way, you subtract. So here is sort of a picture of the whole thing. So here's the freezing point of water, boiling point of water, Fahrenheit, 180 degrees between them, Celsius. And so you can just see it's offset. The 0 point on Celsius is here. The 0 point on Kelvin is 200 and, I don't know why they did that, but it's 273 degrees lower. Technically it's 273.15, but we're just going to use 273. And that's really all I have to say about temperature scales. There's not much more to talk about other than that. Just be able to just make sure you've memorized this conversion factor. Make sure you've memorized the 273, and make sure you can get from one of these to the other. I'll give you one of them. And that is it for Chapter 2.